Hello, everyone. Welcome back to the AKS community channel. My name is Josh Duffney. I'm your host for this net, and I have a new guest with me, a coworker. I think you joined our team. Was it the beginning? I don't know. It's been a couple months, maybe 6 months now.
Something like that. Something like
So
that.
anyway, this is Yosh. I will let you introduce yourself, kind of like your background. Go ahead and kind of fill in. Like I think we joined Microsoft around the same time, but kind of give us like a kind of a story arc for your career, what you've been doing, and kind of like where you are at in the space, like what you work in now. And I think the title of that kind of gives a hint to it. But I want to turn the floor over to you to kind of introduce yourself.
Yeah, absolutely. So, hey everyone, my name is Yosh. I recently joined Josh's team, cloud native advocacy team at Microsoft. I have a background in Rust. I've been a long time Rust contributor, specifically async Rust. That's sort of my field. But over the years, I've also been contributing to WebAssembly, and more recently, the upcoming Wasi Preview 2 release. I've been helping out there. And that's coming soon, and I'm very excited for that. And that ties back into cloud native. So yeah, I'm excited to dive in.
Do you mind sharing us like a little bit more of the background, like kind of like where you got started in technology and just like the
Oh,
kind of the story arc there? Yeah, we can get a little bit of a more get people
yeah,
familiar with
sure.
you and catch your eye on the team at some point. Because when we kind of have a brief conversation before and you
Mm,
kind of talk, it was just an interesting path. But anyway, yeah, if you want to share that, please do.
sure. I was like, yeah, let me just give you like the 30-second thing, and you're like, no, make it longer. Yeah, absolutely. I'd love to talk about myself. So,
Well, here's yours.
easy. Yeah. So, quick background there. I actually did not study computers in school of any kind, really. I went to university. I was like, oh, I don't know what to pick. So I picked psychology, ended up being not a great choice. Very interesting, very fun, but not very um, great career prospects. Or so I realized. I wasn't very good at it. So I was like, you have to be great to like have a good career in it. I wasn't. So at some point I was like, oh, I do like computers. Let me like take some courses at uni. Did some courses, decided like, okay, well, this seems to be going better than any of the other stuff. So I dropped out, found a job at a startup in like doing Node.js. And yeah, that was over a decade ago. So I got very into Node.js for like the first 5, 6 years of my career. Eventually found myself building things like databases and compilers using JavaScript. At some point, I was like, okay, is this really the right language and community to be building like things? I was like precise memory layouts, trying to do that without anything resembling a struct. It's kind of like, okay, um, maybe I should either explore C++ or Rust. I gave Rust a try, and that seemed to work well. Did some things with Rust, and eventually got scouted for the Rust team at Mozilla. Joined Mozilla in late 2018, all through like 2019 up until like early 2020. I was working on Rust proper there. Yeah, and in 21, was it 21 or 22? Anyway, at some point I joined Microsoft as
21,
a
I
Rust
think.
developer
Yeah.
advocate.
Yeah.
Yeah. And yeah, I've been doing Rust. I still work on Rust, despite my priorities now being mainly WebAssembly. But Rust and WebAssembly go really well together. So if there's any gaps there, that I do help out there.
Well, that's a perfect segue in today's talk because Mozilla, that's kind of where WebAssembly came from in the browser. So let's start at that point where so when I first stumbled upon WebAssembly, I was doing a little fourier. So I kind of I came from an operations background and then kind of moved my last job before Microsoft was an S3 at Stack Overflow, and I kept going more and more into programming, and I eventually found Go. But I'm being surrounded by crustaceans now, or rustaceans now, and so I think through peer pressure, I'll probably be jumping on the Rust train pretty soon. Um, but I was doing this dabbling because I wanted to figure out a better understanding of web and build some APIs and Go, and so I bought a book. If you want to do anything web, I had to refresh myself in HTML and
Mm,
CSS, essentially, is what I'm trying to get to, which
yes.
I hadn't done since like high school. Like I made some cool bright red, yellow background web pages in high school, and I did like the Adobe Designer, or whatever, Photoshop, and ran the
Right.
school website and stuff like that. But that was like that was the end of it, and then I moved, into other things. But when I was researching and learning a little bit about HTML and CSS, there's this like vague mention of like, yeah, it's JavaScript, but there's this thing called WebAssembly. And so that's kind of where it started at Mozilla. Do you want to start at that point where like the need in the web browser and like how that evolved? And yeah, I'll just tip it over to you for that.
Sure. So WebAssembly has gone through like a pretty interesting trajectory. Like the very early beginnings, I'm not super familiar with. I know of the existence of Asm.js, which was Mozilla was like, hey, or my understanding of Mozilla was like, hey, wouldn't it be cool if we could like compile, I don't know, like game engines to the web? And they ended up doing that. They built a project that could do that. They showed off like I believe the Unreal Engine or the like Unity like running in the browser using Asm.js, and that was like really cool. But then I believe they ran into like limitations. They were like, okay, well, this is not the best experience because it was like a superset or subset of JavaScript. They were like, okay, what if we made this like a first class thing? What if we like really turned this into its own thing? And that's sort of where WebAssembly started as a start through from Asm.js. Google had its own like competing thing at the time.
They killed it,
Knackle.
maybe.
Yeah, they had it for like quite a while actually.
Oh,
It's
okay.
only like 5-6 years ago I think they killed it. Well, it was like Knackle, which was native code for the web, which was essentially again, I never looked at this. This is all like anecdotal hearsay, so I might be wrong, but they essentially
Sounds
took
good to
like
me.
they took a specific version of the LLVM like bytecode, LLVM compiler backend project, and it has major versions like I don't know every 6 months. And at some point they were like, okay, this is the one that we're picking, and whatever the bytecode format is, we'll use that. And this is the thing that everyone can compile to. And it was like, oh, it's a little bit awkward, and the security model was like not very clear, right? Because it's native bytecode. Like, how do you sandbox it correctly? What's the story there? It was always like a little bit fuzzy. Whereas WebAssembly was like built from day like one to be like fully sandboxed using the browser's like security model, like properly virtualized. There's some trade-offs being made there at the bytecode level. I don't I'm not an expert in that stuff, so I don't really fully understand them. But the outcome is like, hey, it is secure. It is secure to run on the web, and it's intended to be like a polyglot compile target. So any programming language should be able to compile to WebAssembly and then execute it from there. And more recent extensions, such as the Wasm GC extension, make it even like possible for interpreted languages with garbage collection to be more efficiently compiled and like target WebAssembly as well.
Well, I had to do some the research, just like in the definition of WebAssembly. I'll read it real quick because then there's like some words that you mentioned there that I had to double click on to understand. Like it didn't.
Mm.
So like the words defining the thing I'm trying to learn, I didn't understand those words. So then it started a little nice rabbit hole for me. I think this is from Mozilla site, which is WebAssembly is a binary instruction format for a
Mm-hmm.
stack-based virtual machine. So
Mm-hmm.
in that first sentence, there are two words that I need to look up. Like, what is binary instruction format? Okay, well, that just means it compiles to a binary code.
Mm-hmm.
And then a stack-based virtual machine. And so I watched a video, and it was really interesting how while you're coding, you have to be aware of the stack, like as the variables coming off and on, and then it's not just going to stay there for you. You have to
Mm-hmm.
put it back on the stack if you want to return it. Like say you needed to manipulate it, and then you want to return it. So that was interesting, and this might be different in different context. But then Wasm was designed as a portable compilation target for programming languages enabling deployment for the web client. Now, this is talking about Wasm that's supported in the web browser. So that's where it would run, and that's kind of where it started.
Yes.
But the compilation target, that one threw me for a loop too. I had to kind of, you mentioned it, in a couple calls where, yeah, you write it whatever language you want. Now, there's some that have better support, like Rust has a really good support. Go has a little bit less of the same support, but you can compile your
Mm-hmm.
Go application to this binary format, and then assuming
Yes.
wherever you put it, it can run. So in the browser, most of the major browsers have support to be able to run it in there.
Mm-hmm.
And we'll talk about another thing a little bit later that allows you to run it on outside the browser, essentially. But
Yes.
is that kind of like is there anything you want to add in that context of WebAssembly in the browser? Because I was like really thrown for a loop in the beginning like all these words. There's Wasm, there's Wasi, there's let's see here. There's Wasm time. Like there's all these Wasi things. But I was like, where does this all fit? And I started to map it to my mental models for containers. And just to give everybody kind of a big overview, and please, feel free to add context or correct me if the model doesn't quite fit. But in like the context of mapping it to a container, the byte format you can kind of think of as your container image. That's the thing that's produced that you can move, roughly speaking. But then we can talk about WASI now. So WASI is the WebAssembly system interface, and that is what allows it to run outside the browser. So can you just expand on WASI a little bit? Give us kind of an introduction to WASI.
Can I actually still, like, on the topic of Wasm, can I expand on that first?
Yes, please.
Because I feel like that explainer, while technically correct, is maybe a little confusing for people at times.
Sure.
It's like, oh, it's a like virtual, or it's like a stack machine, and like a, like those kinds of words. So I'll segue this to Wasi in like a second.
Not a problem.
But the way I think about WebAssembly is, people oftentimes use words like bytecode. And it's like, okay, what's bytecode? And people are like, okay, yeah, well, the JVM is a bytecode machine. And it's kind of like, okay. Or, is it like Java? And then people are, not really. So a different word that I like, rather than saying, hey, it is bytecode, it is WebAssembly is a virtual instruction set architecture. So virtual ISA, where your computer, old computers have a native ISA, whether that is x86 64 for your, like, most desktop machines, or ARM. There's different ARM flavors. V8 is, I believe, the recent used one for like mobile phones or MacBooks. They all use like ARM instructions. There's different ones. The big what do you call them? Mainframe computers use, again, like a different format. All that stuff is all different. And WebAssembly says, okay, we are an instruction set architecture like those. However, our backend is not a concrete like chip. Our backend is one of those like native instruction formats. So you compile down to WebAssembly, which is a virtual instruction format, and then on the machine that it's run, that machine code is like taken in and converted, or that byte. Those instructions are taken in and converted to like a native like instruction format. So it's like sort of one layer above it.
Well, and that's where it kind of talks about the compilation target, right? So like if all the languages, they have their own compiler, and this is where my knowledge in programming gets a little bit, this is kind of the edge of my knowledge. But if you compile in Go, you compile in Rust, it's doing a different manipulation of that binary, right? And so it's a different format of the instruction. So what Wasm allows you to do is to have kind of a unified format. Like all those languages are compiling to the same type of format, and then what you're talking about is that latter part, like here, the assembly part of it, right? That's being transferred, and then the CPU is getting instructions from that code.
Because what you end up having with like containers is, like, containers are like, you can build your own containers with like C groups and like network segmentation and like isolation, all that stuff. Yeah. But at the end of the day, like when you build a container, you're still tied to a specific like instruction set architecture. Your container is x86 64. And if you want to move this container to like more efficient ARM machines, you need to recompile your container and create a secondary image. Yeah, exactly.
And then have multiple images to maintain, and then you're like, oh, what target am I hitting? I gotta change my commands based on that.
Yes.
So yeah. Okay. Well, that's a good segue for. I think I know where you're going here. All right, go ahead. Take it.
So WebAssembly is, so when we talk about computers, like instruction sets are one part of it. They're a very important part of it. But sort of like the second like big thing, it's like, okay, cool, we can write instructions. Now, how do we make this do something useful? And that gets into like doing things like system calls, or like connecting programs to the network or the file system, or other like APIs which are available. And so, it's cool once we have instructions, but we also want to like do things, do side effects, do IO, do
Well,
interesting like things.
just a little bit on like containers. They're one level on top of the system call as well, because they hook into that, and that's how they're able to do the C groups and do those different operations and use the features of the Linux kernel to create its isolation. And so, yeah, right. Well, previously to what we're teeing up here is you would be kind of trapped in the browser with the WebAssembly. There's nothing that would be able to, you wouldn't be able to interface. There's no way to make the system calls in the web browser. Like that interface doesn't exist, right?
Not quite.
Well, I guess not to the host, right? Because you're in a browser, you're not actually like you can't, whatever the browser is on, it wouldn't be able to hook into the host operating system and do a lot of things that I'm familiar with, like creating files and moving things around on disk.
This gets into like a really interesting question. Like, what is an operating system? Right? Like, so when we say an operating system, we can point at Windows and be like, okay, that's an operating system. Everyone like says, yes, that is an operating system. And then we can point at Linux and we say, okay, this is also an operating system. We're all like, yeah, okay, probably, right? It doesn't have a GUI usually, like that's a separate thing. That's GNOME or GTK or whatever. But like the Linux kernel, sure, that's an operating system. But is the browser an operating system? Right? And people might be like, okay, well, it's operating system like, but it's virtualized. It's not a real thing. And it's like, okay, well, if that's the boundary, then if you're running Linux instead of QEMU, right? Is Linux in that context an operating system? And it's like, okay, wait, that's weird. That's also virtualized. So what is an operating system is pretty like weird. And like once you pull VMs into the context, it's like, okay, this is strange. So I like to think of all of these things sort of be like, okay, let's not try to find what operating system is. Let's just all call them hosts. And all these environments are host environments. And a browser is a categorically different host environment than, say, the Linux kernel is, which again will be different than your $2 microcontroller that can like blink an LED and that's it or something. That is also a host environment, but it is different. And the idea of like with WebAssembly, there were ways of like creating bindings to make it call like system APIs, but they were always bespoke. They were always like custom. We've been doing this for a while. So you'd have your like very custom browser based bespoke interface to like do things, but no standardized interfaces. And like, shoot, how do we segue this? I'm trying to find
so you've defined hosts. So, we can just kind of like agree, like maybe we don't need to define exactly what the operating system is, but there's a host. Like, so what if I want to run WebAssembly not on a browser, that being the host? What if I want it to be running workloads in a data center or on a machine? Like what enables that? That might be a good T.
Yeah. So people have been asking this question. Like, people wanted to like the Wasi preview 1 is the first attempt at this, where we were like, Wasi is the WebAssembly system interface, and this Wasi interface gives you access to your operating system. Easiest cake, right? Like what is an operating system? Well, Wasi says an operating system is a Linux-alike. It is your Mac OS, it is your Windows. And there's a shared set of these things, sort of like a shared subset, and we'll give you access to that. And then people started asking, okay, but I would like to use Wasi on the edge. Maybe in serverless environments, or hey, could we like have Wasi but like target browsers? And Wasi was like, no, we can only support things that look like a proper operating system. And it became a little unclear because like on the edge, you may have some networking, but you may not have a file system. In the browser, you have, for example, HTTP, but there's some proposals or implementations for like also full file system access, but you may not have processes, right? So how do you define these interfaces? How do you create an abstraction layer that can work for any host and expose like the functionalities that are like on those hosts in like a portable way? And that has been the recent development with like Wasi Preview 2, which is Wasi proper, or if you want to think of it like the first like real version of like Wasi. that provide shared interfaces for these things. And those interfaces are defined in something called the WebAssembly component model, or WebAssembly components are the concrete like things that are shared. And does the word ABI mean anything to you?
Not personally, no.
Okay.
Well, one thing that I like to do is to zoom out, so
Yes.
that way we can go even deeper. So if
Yes.
we
Okay.
zoom out, we've got WASI in the browser,
Yes.
and you can. There's good examples where you can just like call it with JavaScript and it does things, and that way you could actually write. I think Figma does this, and maybe you have some examples where some of their code in their operations is actually written in C or C++ and compiled into WebAssembly, and then they're able to basically deliver all that on the client within the browser. And then Wasi is what is being developed and worked on with Preview 2 to allow you to interact with an operating system, right? Some things on the like the network stack that's there,
Yes.
and the files and so forth. Now,
Yes.
the big gap that I had in the beginning here is like, okay, it makes sense in the browser. You can like maybe you don't want to write JavaScript for these things. C is just a better language for this particular use case, better performance, blah, 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 right? Whatever it had. That made sense. But now I'm like, okay, what does it offer on like my native land of virtual machines and system? Like, what do I gain in that sense? Like, and like, how does that work? So, like in the container world, like, okay, I get
Yeah.
it. Like, basically Docker containers taking advantage of a bunch of Linux features or Windows features that allow isolation, they're lighter, whatever. Like, how does that map into like, how is WASI improving that experience? Like, it's the new version of containers, and containers are the old VMs now. So that's like the little sentence that made it click for me in our call the other day. And so let's dive on that. Like, what is the benefit? So like we have the system interface, but like, why would I want to use, like, what do I get from it? What are the benefits, like from isolation and performance, like all that kind of stuff.
Sure, absolutely. But by the way, that's a spicy take that I don't remember saying, but I
That was my distillation. So what I like to do is like take all the information and like condense it into a maximum, and then it just sticks in my brain. And it might not be fully true, but at least gets the conversation starting, and it's a good anchor. So
I'm also not saying I disagree.
take it with a grain of salt, everybody that's watching.
Yeah,
container still. Well, it's a good example where in the industry I've been in it. I think 15 years will be next year. So I know a lot of people have been in the industry longer, but it's just that amount of time was enough to see some transitions. I started in college and it was like, oh, virtual machine. I was like, how could you do this? I have 10 machines running on one machine. And then, containers came about, and now there's this third wave that's coming. And so I'm starting to see the patterns recognizing. So it might be a little bit spicy, but it's also that pie graph is starting to shift. And like we talked a little bit where, like the dart throw, I won't put names here, but like maybe WebAssembly is in the Docker Inc. stage, right? Where it's kind of, it's at that cusp with the growth curve kind of thing. And so that kind of sets the stage. But it, just like when I was trying to convince my employer to start having their development teams create Docker files, like how do we get these in containers? That same transition is going to happen with this. And I kind of, let's dive into a little bit about like, how does it achieve its isolation? And then like, what makes it so fast? Like containers, you don't need a full operating system, it's a subset and it runs on there. So that's its isolation, and it's more condensed, right? You can get more capacity. And then WASI allows you to take that a step further. Let's dive into that a little bit.
Yeah, for sure. So
the birth and death of JavaScript.
Huh? What was that?
There's a James just posted this.
Let's check it out. Oh, yeah. No, it's great. I like that. I've seen that talk. Like, it feels like oddly prophetic if you like watch it back, where it's like, yeah, okay, that seems roughly like we're on track. Let's hope we can skip the war part in that thing. But
yeah.
But yeah, so I think it's very interesting to like think of. Ooh, hold on, my cat is trying to nap on my keyboard, which might close Windows. Let's not do that.
Alt F4.
So I think it's interesting to like think about performance of anything in like the complete system. So with a virtual machine, when we say, hey, we're having a virtual machine, like what are we virtualizing, right? Like what is within the virtual machine? A VM says, hey, I'm going to take every single device driver out there. I'm going to take like all of the interfaces, load an entire operating system, the kernel is part of it. And then I'm going to load your like file system and applications, and that becomes your VM. And sometimes you can even like get a full like graphical interface on top of that. That is your VM. That's all within the thing, and it has standard interfaces to virtualize hardware. So you talk to virtual hardware, and that's what you get. And I remember like in, I don't know, 2013 or whatever, I could run 2 VMs on my laptop, and that was it. Whatever the HashiCorp like stack was, I was like, oh great, I can run 2 VMs. That's exciting.
Vagrant, is that what you're using?
Yeah, that's the one. That's the one.
Yeah.
And like, it would take like 5 minutes to boot or whatever, something like that, like in terms of like minutes.
Pre-solid state drives, and yeah,
I might have had an SSD.
you might have splurged. They were pricey back then.
I had what was it, a fancy, not quite a netbook, but like slightly fancier, like a Samsung. I don't know, but it was like pretty slow, right? And like Docker came along and was like, hey, you know what if we didn't virtualize all of the device drivers and all that stuff, and we didn't like boot up a new kernel? What if we shared the kernel and we just made the file system and all those things, if we isolated that? So you can kind of think of it as like isolated processes. So rather than booting up an entire new kernel, you create a special process which has a special view onto your like disk, and it can't break out of it. Or later was proven it can. It's not quite a security boundary, but like it says, here's your isolation thing. And that rather than running maybe like in this low tens singular on my laptop, like VMs, you could run tens up until like hundreds if you had like good like hardware of containers side by side on a single computer. That was like a big boon. No longer minutes to boot up a container, but seconds, because we're virtualizing fewer things. Wasi goes one step further. It says, okay, what if we did not have a file system? What if we did not attempt to like virtualize, or like what if we did away with like the concept of like we are running in Linux and we're going to pretend we are running in Linux, and that is the abstraction we virtualize. And when you run in Linux, you have things like, hey, here's the command line that we have, here's nvars that we're setting, here's like a bunch of like process spotting is a thing, fork join is like a whole model, and all the integrity around those things. Like you're isolating sets of processes essentially. What if we didn't do that? What if we said like, here's your code, these are instructions, and we're going to run these instructions, and that's it. And then we create a standard interface for these instructions to be executed and to do interesting things. But it does not mean you have a POSIX compatible, like, full POSIX, like, or a full Linux, like environment that you can do whatever in. Turns out that's way more efficient. You can virtualize rather than like, the tens of VMs or hundreds of containers. It's like, no, thousands of, Wasi processes, or what do we call them? Wasi components, I guess, like side by side, and like they spawn instantly.
No, that's a perfect tee up. I'm trying to find Rusanovich's talk here. It is on the VM, so it's like a couple minutes. Let me drop this into the chat. Well, that's not gonna display well. There we go. We'll just put the YouTube link, and I'll put all these in the show notes too. So afterwards, there'll just be links that you don't have to type out. But it's that. But you can also check it out. I've got a couple links that I'll share in the description here of like where I went through to get this information. Just to kind of, I spent maybe half a day yesterday just reading about it, try to understand and map to the models. So, I mean, really to recap, I love the zoom in, zoom out in these conversations. And so if you look at, it's just another continuation of the capacity story, and the scaling problem or scaling solution. Where we had one VM and we ran. I remember being the sysadmin. It was called Mail Server many jobs ago, but it was this 2003 Microsoft server instance that was the domain controller. It was the print server. It was a physical box in a server room and had all these responsibilities. and it was a print server. So I was like, oh, the print server kicked it. I'm going to reboot it, not knowing that I was going to take down Active Directory. If I did that, no one's going to be able to log in. So lesson learned there. But then virtual machines came and solved that. But then, we ran into some capacity and then containers. And again, so it's like another iteration of that where it's now we're dealing with the process. And so this is a gap in my understanding. Is WASI what is creating the process for it to run on the host, or like where is that actually being done?
So, hey, the answer is it depends, and there's different ways of
or is that up to the
approaching this.
runtime that's doing all that? Okay,
correct. So there are 3-ish ways in which Wasi is being deployed or can be run today. First one is JCO, which is a Wasi implementation for Node.js. And the way that works is it says, hello, Node.js has a native Wasm runtime. And what it does is it implements the Wasi, the standard operating system APIs, and exposes them to the runtime. And essentially Node.js is on the hook for ensuring that we do the implementation right, and then you have code running within your Node.js process. And that's the first one. The second one is basically you spawn a process which has a Wasi runtime in it, for example, Wasm time, and then you load your Wasm program inside of it, and then isolation happens through that runtime. It's kind of the same as with JCO, but in that case, Node.js is on the hook here, or however you deploy Node.js is your boundary. Here it is at the process level, which is a little bit different, but the runtime says hey, at the boundary, I ensure that whatever happens here can't break out of it. And there's a lot of verification going on to ensure that nothing can break out of it. But then your isolation boundaries at the process. I'm not sure if you were asking about isolation boundaries. Maybe I'm shooting.
No, that's perfect, because I just got done doing the deep dive into how to I've used containers for a long time, but how are they working? What is going on the host? And so I'm understanding oh, okay, well, you do this and then you add processes to the C group, and then it's kind of constraint there. And so if you have WASI, in my mind, is kind of mapping to the OCI spec of here's how your boundaries should be, right? Because that defines the C groups, it defines the permission sets you're going to have, it defines your mount points and blah blah blah. It does all that, and then the runtime is the one that is actually spawning them and creating the containers and so forth, which could be containerd, or it could be your Docker daemon that you're running. And so that would be Wasm time or one of these other runtimes. But the specification in WASI is what's defining what those should be implementing. Is where I'm getting where I think it's clicking for me. And then, so this is a good segue for preview 2, which is
There's one more. There's one more.
Okay, yeah, go ahead.
I covered 2 out of the 3.
Okay.
I also should mention capability-based security. It's a word I kept forgetting. I was it provides isolation because of capability-based security. The process, it's fine to just have it in a process, or fine, good enough for most cases.
Does that word capability, that's not synonymous with Linux capabilities, or is it?
Kind of.
Okay.
Kind of. I think I'm not super familiar with Linux.
So that's just what this thing can do, right?
Yes,
what this process is allowed to do to the host, right?
Yes. So the way Wasm time, using Wasm time as your isolation boundary is mostly fine, because what happens is say you run a program or whatever, and it doesn't explicitly ask for network access, it won't have network access. So how does a breakout from within Wasm time to the outside happen to I don't know, escalate, get privilege escalation to access networking? There is no operating system within that. It is all just instructions which are being executed in a very constrained system. So that's mostly fine. The third way, which is the way we're looking at this, and indeed Mark Rusinovich's talk, which is okay, we mostly fine is not good enough. What we actually want is we want the hard memory isolation boundaries, the hard segmentation, the full guarantees VMs give you. And that is what Hyperlight does. So Hyperlight is lightweight VMs, microVMs, I believe they call them. And it's like, yeah, it's a full isolation of an actual VM. If you break, and within that VM, we then run Wasm time. And then if you manage to, and we don't think this is an actual thing that is expected to happen, but should it happen, someone breaks out of like Wasm time somehow. Great, you're now in a VM, which is like a linear slice of memory, and some like you would need to like break out of Wasm time, break out of the VM to like get any form of escalation, and that's like about as secure as you could possibly be.
That blew my mind when you first told me that, because I was diving in, and you can allocate limitations for what the container can have for its consumption, but you're not limiting where it's able to write in memory. And so with that particular, with Hyperlight, you literally, like, in memory, it cannot go outside these blocks.
Yes.
That's the level of isolation that you get, just like you would with a VM. So you kind of get the benefits of the containers, but with the isolation of a VM. Is that a good summary of that particular
Absolutely
scenario?
Yes.
Fantastic.
Yes.
Okay, let me find Hyperlight so I can put that in there. I think Aaron had a really good blog post on it. Here it is.
Yes.
Again, all these will be in the short.
So Hyperlight exists, but is internal, but we can talk about it, but it is not yet public. However,
Aaron posted on his blog about it, so we can talk about that.
Yes, exactly. But
so
yeah,
there, I shared it in the chat. The link to that Hyperlight overview, and then that has another.
I think Mark Rusinovic's talk is probably like the coolest one out of all of the Hyperlight things, where it's like, oh yeah, I'll just spawn like, I don't know, 2,000 VMs. And it's like, okay, we're all expecting like this will take a while. And it's like, no, 1.7 seconds, right? How much memory for 2,000 VMs? That's like, what was it? Like 3 gigs for 2,000 VMs, which is like
3 gigs, a little bit over 3.4 or something
30,
like that.
30 megs per like VM or whatever. And it's like, okay, Jesus Christ.
Well, and it's interesting because getting to this level, I've had to redefine words that I've just kind of taken for granted, like virtual machine. And Aaron does that post that I just listed there. He does a good job of explaining, like, I don't mean virtual machine in the traditional sense that you probably think about virtual machine. I mean it in this way. And so I'll kind of leave it to the blog post for that. Looks like we have a question from James. Let me just throw it up here and see. So all the current branch prediction issues we are seeing with CPUs won't affect Wasm. Not sure.
I'm guessing this refers to things like Spectre. Prediction issues, I assume, mean security issues. And my understanding is that things like Spectre are like they are caught by VMs. Sorry.
Oh, go ahead. Yeah, go ahead.
Oh, yeah. my understanding is that like Spectre and etc. like they're issues if you don't flush your caches between like context switching, and like you want to do that for like performance reasons, and like so the Linux kernels had to patch all that stuff, but VMs flush everything. Not a security expert, not a security researcher. It's not my field per se. This is my layman's like understanding. Where it's like if you're running proper VMs, like VMs are not affected. Hyperlight, for all intents and purposes, is a proper VM. Like it provides that degree of assurance. So if you are running WebAssembly inside of Hyperlight, then indeed WebAssembly is not affected.
So to his question, it depends on the runtime and how it implements the boundaries.
I think so.
It sounds to be determined, but yes, I think so.
Yes. I like here's the other like part that I'll add to this. Like the Wasm time people are so incredibly competent. Like for them to not have accounted for this would be extremely surprising to me. So I'm not going to say that, running Wasm time as your thing will be affected by this. Like it may also not be affected, but I don't know for sure. Like the VM one almost certainly, like it's fine.
I'll second that with just reading the documentation. It's very humbling. Like I've got a lot to learn here. It's essentially the gist that I came away with after my half day of research yesterday. I was like, yeah, this is pretty deep. We're getting a lot lower level than I've ever had to worry about, which has really been fun for me. So
Hell yeah.
I think the last thing that I want to touch on before we wrap it up, coming close to the hour,
Mhm.
and so we've got the Wasm time, but let's say like it's not giving me what I want. Like where does Preview 2 fit into that? Like how can I create, like where does the component model, like what
Right.
is the component model? Where does it fit in? What is it addressing? Yeah, those are my questions.
Yes. Yes. This is my favorite. So what are components? What even is the component model? What are these things we're like trying to address with it? Like, why is it relevant? Those are great questions. And I think the best entry point here might be when we program against a host environment, say Linux. The Linux kernel says, "Hello, I provide these APIs," and it gives you like I don't know, a whole bunch of APIs, and then like, okay, I'm running this version of the Linux kernel. That means these APIs are available, and then you program against that. Um, so those APIs, they are like system calls, are what they're called, and they have a calling convention. This is usually in the C programming language, which is used like, okay, so if you pass this struct with this layout and give it to instruction this one, then this thing happens, right? And that is the interface for the boundaries. And then you can have different C programs that talk to each other. C is the universal like ABI language for most host environments. Not true for JVM, but like Linux, Windows, etc. It's all C. And then with libraries, it's the same thing. It says like, hello, I expose these function calls, and if you call me this way, I will do this thing, and that is how you make these programs talk to each other. And this sort of system of program or like live programs talking to other programs, we call that layer, that integration layer, is a ABI. It is calling conventions. It is the way I like to think about it. It's like it's a type system with an encoding. So you have different types, things like structs, numbers, strings, even like can be as rich as you want or not, and a specific like way that they are encoded to like concrete types. Swift libraries have like Swift to Swift communication, does things like using dynamic virtual dispatch and pointers and stuff. C to C communication is different. When we say FFI, it's like, hey, I take this program, for example, Python, and it knows how to talk to C because it knows how to talk C ABI and communicates with each other. Wasi and Wasm components, Wasm components and component model is a new ABI. It is an ABI format. It says this is a way in which you can get two programs to talk to each other. And what I find, what I like, what I actually really love about like the Wasm component model is it's very richly typed. So the ABI format is defined in an interface definition language, which is not quite a programming language, but says like, hey, here's types and functions, and these are the shapes, and it is it's properly type checked. It is like human readable. It has high level notions like here's a result type, here's an option type. It does not have null, and it says this is the interface by which like things can talk to each other. And when you write a WebAssembly component, you say, okay, this component exports this interface and it imports this other interface. So if you're writing a web server, you'll say something like, this web server imports HTTP networking and it exports, whatever the server interface is, etc.
I was trying to find, it might be good to see an example. I was trying to find maybe it's in the spec, where their examples are in maybe I'm wrong, the WebAssembly component model. Because then we're talking about like, that's defining a WIT file. Trying to figure out where that.
Should I just pull up a random like WIT example?
Yeah, just pull up a WIT example. So that way we can give some kind of like visual context to that that layout. Because then so essentially what's allowing it to do is for two WebAssembly programs to be like, this is its means of communication, right?
Yes.
Okay.
Here, I'll paste it in our chat here.
Yeah, I'll pull
and
it up.
then
Yeah.
this is just a random file I found. Probably some of the more complex, like, don't look at the entire thing because it's like, here's TCP, and like the TCP state diagram is like intense. But just to give you an idea, this is an interface called create socket. And it exposes one function. It says, hello, here's a function, create TCP socket, that takes an IP address family and it returns a result of either a TCP socket or an error code. And then, just taking this in isolation, someone like a host runtime which implements TCP can be like, hello, I export this interface. And something like, I don't know, a database or like a server or whatever, maybe like, okay, I need TCP. And it says, I import this interface. And then, you can connect the two and it says, okay, something that exports it is here, something that imports it is here. Work together.
So that actually makes it available on the higher level language. Like, say I'm writing a Go application. This is what's defining the WebAssembly things that I can then use in my program. So it does require you to change your code a little bit to compile to it, obviously, but
not per se. The goal is for standard libraries, and this is also like a fun. I mean, you said we should wrap it up, but if I can like add maybe like one more thing here.
Yeah, please do.
For example, Golang. If you compile for the Wasi Wasip one, Wasi P1, it exposes the standard lib, the Golang standard lib, and under the hood, all those like high level interfaces target Wasi Preview 1. I believe they're also working on a Wasi Preview 2 target. Rust definitely is. We are. That you can just take your existing standard lib types, like hey, here's my TCP socket, or here's whatever file type I have, and it'll like under the hood, it'll target those like Wasi system calls. Maybe also important to like sort of name the difference between Wasi and Wasm components. Wasi Preview 2 are like we're renaming it or redubbing it unofficially, maybe officially one day, to WebAssembly standard interfaces rather than system interface. And it is a collection of standardized component interfaces. So we define, this is what a TCP socket looks like. This is what a file looks like. But also things like, this is what an HTTP interface looks like. And different environments will provide different interfaces. So Windows will be different than, I don't know, a serverless function on the edge, but they're all using still standardized interfaces. And they may even like share certain like types.
That makes sense. I mean, yes, it's a very, I know it's exciting. Like it's a deep rabbit hole, and I'm getting way closer to. I mean, it's kind of native to Rust's nature, which is the system programming. Right? So, like, there's a good question here that we can wrap it up from Erwin here, and it was, he mentioned this a while ago, but I'm seeing a lot of Rust being used for Wasm. That makes a lot of sense from what you've said. And then what are your thoughts on it? Well, my thoughts are I'm going to learn it. So I picked up, I don't know if this will blur it out, but you can see the fighting guy. What's the title? It's not going to tell me. It's Rust in Action is what I'm currently reading. So I'm skilling up in it personally. Adding another language to my tool belt isn't gonna hurt me. It's only gonna help me. So I'm excited to dive into it. So my personal opinion would be dive in. I think yours would be probably the same.
I am quite biased.
Yeah.
So my hope is you won't need to learn Rust to use WebAssembly. There's a lot of overlap between the WebAssembly groups and the Rust groups. Rust being a systems programming language makes it very easy to compile to WebAssembly. A lot easier than, say, Python, which is more complex. It has a garbage collector. It has like all sorts of references. So that's a bit trickier. I want WebAssembly to work with all these languages equally well. But given I'm a longtime Rust programmer, I'm quite biased. I should say I like Rust a lot. If you have the time, I think it's often worth the investment. So yeah, Hope that makes sense.
That makes total sense to me. Yeah, and I've been in the Go space for a while, and I said I just hit, like I think it's maybe 2 years, 2.5 years. So I hit that competency level where I'm feeling pretty good about myself. Like I can do that. I can solve problems in it. And I'm like, do I really want to start over again? And like, confuse myself, like for the long time, I would still put dollars as sort of my variables because coming from PowerShell and then Ansible and stuff like that. But I think it's going to be worth it. And there's a lot of context. One thing that I will say is try to learn the language in the context that it's most used for. So we were talking about this the other day. If you want to do some kind of CLI stuff, that might be a good first project for Rust. So and that'll probably be the topic of a couple live streams. I think the next one, if this has been interesting, and this has kind of been a topical conversation, but I think if there's interest, maybe I'll do a poll on Twitter, X, and various platforms. But just diving in and walking through some of the tutorials and getting my hands dirty with it might be a good topic. And then I can ask when I get stuck. I have you to ask, which has been a blessing. So I just want to thank you for joining the live stream. I always learn a ton from our conversation. So thanks for coming on the show, and we'll kind of wrap it up there and hopefully have you back on in the future.
Thank you for having me on. Thank you for letting me rant. I believe we started with in order to explain Wasi, first we have to define what a computer is. So, it's been great going through it.
Yeah, thanks for the people that followed the story with us that are still watching. But yeah, I think so. We got to do the CTA here. So make sure you subscribe to the channel. I'll be doing more scheduling things. I finally got this one ahead of schedule. I've been really bad in 24 hours in advance, I'm going to force myself to do a live stream. So I'm getting better at it. You'll have a little bit more of a heads up, just like this one. And thanks for the comment, Dave, there. He enjoyed the stream. And again, I want to make sure I'm saying your name. Is it Yosh?
Yeah.
Or Yosh?
I mean, I'm good with anything. Yeah.
Yosh. Well, Yosh is easier because it rhymes with Josh. So we can go with that. But thanks again for being on. And we'll hopefully have you back in the future. And thanks everybody for watching. We'll catch you on the next one. See you.